What's up, friends? Today we are here back again with the Meepo MLR. And in this small box we have some components courtesy of Flipsky, and we're going to be upgrading, maybe side grading depending on how the specs change, this board from the JKESC over to Flipsky's ESC, as well as changing the remote from the standard JK remote over to the VX4 Pro. I'm really excited for this upgrade because I, for one, like the VX4 as a remote, and I also think that this ESC is going to have a very different torque curve and responsive action than the JKESC. So I'm really excited to see how much power we can coax out of this thing. I'm intending to redo the performance testing with this new ESC and see what the difference is. And then after this upgrade, we're going to do a part 2, and we're going to really crank up the power. We're going to put a 16S 4P battery on here and put either a D100S or something like that on here and really crank it up and see how much we can squeak out of these motors. So hopefully you guys enjoy this series. This is going to be part 2 of Void My Warranty. So let me know what you think down in the comments below, and let's get right into this upgrade. All right, so first off, shout out to Flipsky for sending over these components. This was my idea, for the record. I requested these components from them and they agreed to sponsor them for this video. So inside here we have the VX4 Pro. Whoop. Some of you are probably familiar with this remote. A lot of people on vesc boards use this. I really like the form factor, and the VX4 Pro has some great upgrades like the metal thumb wheel, better connectivity, different data on the screen, and the ability to trigger lights and a horn. And the receiver actually has, if I can get it out, I believe the receiver has outputs for that. No, the ESC has outputs for that, which the VX4 Pro can trigger through Flipsky's own ESC. I'm not sure how it interacts with regular vesc like outputs, but we're not exploring that yet. We'll do that when we upgrade to the D100S later, because I definitely want to keep using the VX4 Pro. So we got that all ready to go. And then we also have the Flipsky ESC at the bottom of the box here. They actually sent over the horn and some headlights. I think this is the tail light that works with their ESC. It's pretty big, so I don't think I'll be installing it on here, but if I ever use this ESC on a different project, I'll definitely put it on there. Just for trying it out's sake, we'll probably throw it on the ESC while it's on the bench. And I think this one is the horn, yeah. So this is a little horn that you can attach to your vehicle, whether it be E-skate or not. It's just sort of like a car horn to let people know that you're there. Again, I don't really think that the MLR needs that, but I'll probably try it on the bench just to see what it's like. We got some headlights here, and then the ESC at the bottom. If you're wondering what ESC this is, it's their FT85BD, which is not a vesc technically. However, it does use similar software called Flipsky ESC tool, and you program it in a similar way. I'm not sure how much of the hardware is similar to a vesc, but they aren't marketing it as such. So I'm really interested to see what kind of performance this thing offers. They claim it can do 100 amps per motor, which is pretty good. I think that's quite a bit more than the JKESC does. So we'll have to see how that goes. It's got bare wires on here, so we'll have to solder on some connectors, which they did provide, the MR30s, or sorry, the MR60s. And we'll solder those on, and then there's a number of connectors on here. We have a USB, which actually you can run out somewhere, which is pretty cool. I didn't know that. You got your power button, you got ADC inputs, UART inputs, CAN inputs, and then you've also got connectors for your Hall sensors. Hopefully these Hall sensor connectors are compatible directly with the ones on the MLR, and I don't have to change the connectors out, but if I have to, I will. So yeah, that's the ESC we're going to be upgrading to. Looking at this right off the bat, you might immediately notice that this ESC is not going to fit directly in this enclosure. The camera's not quite focused on it, but this ESC is almost the size of this entire enclosure. So we're going to be redesigning this enclosure, printing one out, putting it on here, and mounting this ESC inside. And I will be providing a way to acquire said enclosure, whether it be through my website or some other means. I'll probably end up linking it in the description of this video on how you can get that in case you want to upgrade the MLR on your own. So first things first, we're going to have to disassemble the rear end of the MLR, take the ESC enclosure off, see what we're working with in terms of connectors, and then we'll get on to designing a new enclosure or adapting one of my existing enclosures to fit this new ESC. Fortunately for us, getting in here is really not all that hard. There are just 4 Phillips screws on the top, which need a very small screwdriver apparently. Oh, I might have to pull out my other one. There's actually some stuff stuck in these screws. Bit of a design flaw if you ask me to have such tiny Phillips screws on top, but let's see what we can do. Not really sure what was stuck in there, but I think it was probably some bits and pieces from grip tape of another board that this rested against in my car or something. But if you get stuff stuck in your screws, you definitely want to make sure to clean them out, because stripping these would not be fun. Fun fact though, the reason why Phillips heads strip so easily is because they were actually designed to cam out, per se, the driver that's putting them in before the screw broke. And the reason for this is because they were designed way back in the day when automated machines were just starting to assemble things, and they wanted an easy way to make sure that the screws in cars wouldn't break before the head of the fastener did. So the Phillips head was designed such that it would fail before the screw, which is great for that day and age, not so great for nowadays. And that is one reason that I much prefer the Allen keys or Torx fasteners. Anyway, pretty easy to get in here once you get those screws out. It's just 4 screws. Then you have full access to the ESC. I think to get this enclosure off, we're going to have to unscrew it from the bottom, which does have 4 Allen screws, I think 3mm M4 screws. So we're going to take those off in a second. But for now, we can pull off these cables. And I actually use these same cable glands on my board. I don't know if it's the same size. I use PG 13.5, I think. These might be slightly different, but we'll probably reuse these on the enclosure that I swapped this with. And one thing that I don't know about attaching is the charge port on here, because it's just a straight up XT60. I'm not sure how it routes through the enclosure, so we're going to find out in a second. Flip the board up and you can see the 4 screws now. 1, 2, 3, 4. We're just going to pop these out real quick. We'll probably use these 4 holes on my enclosure that I designed to fit this in as well, since they're already here. Might as well. Probably going to need to take these rear ones out by hand though. Looks like we might be in luck for the Hall sensor connectors. That would be ideal. And the charge cables. Ooh. Which are molded in. So we'll have to check. We'll have to take off this skid guard on the bottom and potentially the enclosure and see if we can find the connector on the other side, because they are kind of permanently attached to this enclosure. Alright, so I ended up closing this back up because I don't need to get in there anymore. There's 4 more screws here that will be needed to be taken off to get to the cable path. These have a nut on the bottom side, so you're gonna have to hold that with something while you unscrew the top side. Well, that's the cable cover off. Piece of formed sheet metal, looks like. Heavy. Oh, perfect. There are your connectors right there. So we can just go ahead and pop these off. Don't even have to undo the battery enclosure. And it's nice to see here that the MLR is using an anti-spark to prevent ESC damage when plugging it in. On the other hand, the base plate here is pretty tight on this connector, so I might have to loosen the screw so I can get it past. Alright, so now that is off, Alright, so now that that is off, we can get some important information. One is this hole pattern, and then another is this, which is interesting. This is actually really good for me because this means I can make a drop-in replacement. That's super easy for any of you to do, should you choose to do so. So we'll have an XT90 coming off with approximately that much slack, and an XT60 mounted up for charging. Pretty straightforward if you ask me. I think this will be really easy to make a new enclosure for, just because it's a nice flat deck up here. All I have to do is avoid the bolt holes, and then the cables for the motors can come in either on the side or on the back, similar to how they did it here. It could also go in the top, but that probably would look a little bit weird, so we'll see what I can do with the design. Probably going to end up going on the sides. For those of you wondering about the dimensions of this whole pattern, seems to be about 97 millimeters in width. Strange number to pick, but I guess it's just how wide the deck is. And then the other dimension, it looks to be about 80. So 97 by 80 in a square or a rectangle. And those thread directly into the threads on here. These are M4 tapped threads. They go directly into the aluminum. All right, so we've got the Meepo enclosure here. We have this enclosure that I designed a while ago for other boards, which I think is maybe a little bit oversized for this application. And then we also have the FT85BD here, which does fit in my enclosure, but if you look at it compared to the top of the truck, it does take up quite a bit of space. So the enclosure here is going to be bigger than the stock one for sure. Hopefully not too much bigger. And then we've also got to stow cables inside. I did check the Hall sensor connectors, and they're pretty dang close, enough that I'm just gonna shove them in and they should stay with some tape. But I think it's probably like 2.54 millimeters versus 2 millimeter pitch. I'm not 100% sure, but in any case, they'll work. So next, we're gonna go ahead and design an enclosure. All right, so let's go through a quick design crash course. way I usually start these enclosures is with the ESC. So I went ahead, measured the ESC, and made it in CAD so I can fit the enclosure around it. After that, I usually start with the base plate. So you can see that here in my model tree, I have the base plate. I made these each as components to help split them up better. And we can sort of step all the way back through here to see the beginning. Sketch a basic shape as your base plate, put in your hole patterns. Add additional features that you need. That was to clear the bolts that are on top of the Meepo deck. Added a hole pattern for the outside. Added some additional strengthening. Some fillets. Hole for the cables. And then finally a gasket channel and some chamfers for the new bolts that I ended up switching to after I got partway through the fitment. After doing the base plate, you can sort of just bring the walls up from that. We can step that back through this one. Just start with the walls extrude. And then I started working on the XT60 attachment. So I imported this model from GrabCAD of the XT60 that I was going to use, which I already had. I made that feature, extruded it into the wall, made the holes for the cable glands, and then I later realized that I needed to make these channels. I added some inset holes for the nut, and then I ended up cutting out the sides. I don't know what happened to my screw through holes. Something glitched out there, but I'm sure we'll get there. Next up is going to be the lid. You can step into that one. The lid's pretty simple. Basically just extrude the shape of the walls, including the center part, and then add a hole for the power button with some standoff to pop it up a little bit, and then add some reinforcement. I did kind of a interesting design, and then of course pop through all your holes, which for some reason aren't showing up right now, but that's probably just a glitch. Alright, I fixed the whole glitch. I don't know what was going on there, but anyway, I added a piece of hardware in here to make sure I had enough thread engagement. It's pretty tight, but I got the 3 threads that I wanted, and it ended up working out just fine with this 10mm M3. I also designed a plug for the XT60. This is supposed to be printed out of TPU. I haven't printed one out yet. It should work in theory, but the goal is to just keep junk out of this. Although I don't really think that it'll get anything in it since it's rear facing, but better to be safe. As you can tell, this has taken quite a few versions to get to this point. What you're seeing in this model spin right now is the final version that's actually on the board right now. As you'll see in the next couple clips, there were a couple different versions that I printed out before getting to this point. So while this may look simple, or maybe not to some people, but for anyone that's done CAD before, this is really not that complicated, but the time is spent, you know, making things fit, iterating through little issues, making sure clearances work out, and you know, that's what you pay for when you buy a design like this. Alright, so I went ahead and designed an enclosure in CAD, which I'm sure I'll show a little bit of that before this clip. But we printed out our first prototype, and this is sort of just meant for a fit check, so you'll have to excuse the Ronald McDonald color scheme. But I like where this is going, and I think this will definitely work. I just need to get some things tuned. these cables bending at this angle make me a little bit uncomfortable. I think it'll be okay. We might just have to feed a little bit of the wire out that way through the gasket or through the gland, so that there's a little bit more slack on these. But this location will work. One thing I do need to do though is, as you can see here, I sort of chopped off the top part of each of these holes. I think they do need to be slots because the cable gland nuts can't come off over these connectors, and I don't want to take them off. So we're going to make them slots. That will make it a lot harder to waterproof it, so I need to think about that a little bit, but maybe we'll figure something out. If it doesn't work out, I'll have to change the cable glands, but that would be super unfortunate, so we're just going to have to see what we can do. But for now, going to go back to CAD, change these to slots instead of holes, and I think that'll probably be it. I think the rest of this will work out well. I like the size. I didn't try putting this in yet. I know that the hole pattern is correct on here. It's more a question of like how well it fits with the walls. So that'll go like that. There's 4 holes there that will have inserts in them, and you'll just bolt it straight on. Pretty simple. This red base plate can be made out of metal alternatively. For now, it's just going to be 3D printed. But it looks like the size is all right. Let's see how the walls fit on all these cables. I need to unplug the ones that I'm not using. Cable go down through the middle. Fits in there. We're definitely going to have a bit of a squeeze with the cables coming into the enclosure, which I already sort of foresaw when I was doing this in CAD. But I think there should be enough room to squeeze them in there. They are cables after all, they're not unbendable. I think that'll work. It looks like we need a little bit more height as well. Maybe. We might be okay on height too, actually. Pretty much nailed the size here. I'm really happy with that. Alright, well, this looks like we're almost there, so I'm going to make a couple modifications and we'll come back with a new test print. While I'm unplugging cables here, I will say the one thing I do like about this ESC, which may be controversial, is that it has locking connectors for all of these vesc data inputs, which is really nice for longevity. It's not as nice for compatibility. However, these all have male connectors on the ends, so you can easily adapt to, for example, a standard UART connector. This is actually the ADC connector, which we're not going to be using, so we can unplug that from each side. There is a UART connector here with an adapter that will fit on your standard VESC JST connectors, just like that. And that's what we're going to use to connect up to the Flipsky Bluetooth module to communicate with the ESC. Alright, so I've been messing about with this design a bit. Came out with my completed walls. Got all the inserts installed. Went through a couple iterations of the base plate trying to get the gasket tolerance right. Now we got a gasket in there, so we're going to assemble this. This does require countersunk screws. I think I have enough of them. So we're going to assemble this onto the walls, and then we'll put the walls and the base plate onto here, and then we'll see if the ESC and stuff all fits inside it properly. And if it doesn't, then I get to do it again. But I think it'll all fit. Alright, so more work has been done. I've got the enclosure assembled, got screws in, got inserts in. I think it looks sick. I'm hoping it'll fit up onto the board just fine, but we're going to find out in just a second. Bolt it down and see what happens. Quick test fit of the ESC. Seems like it's going to be pretty tight, but I think it'll just fit. I'm mostly concerned about the connectors on here fitting up well. and being able to be stowed. But we're just gonna have to see once we get them soldered up, because it's hard to tell at the moment. Alright, so I have it mounted up with the 2 front bolts at the moment. I think it looks pretty sick. Problem I'm running into though is with the inserts. Normally these have treated me really well, but I had to use really thin ones for this base plate thickness, and I ended up pulling one of them out. And then these rear bolts are basically impossible to access with the link in the way there, so I can't really screw that in properly. So I think what I'm going to do is use some countersunk M4 bolts and put them through the top with a nut on the bottom. I'll probably just leave this corner out for the moment and put one of the countersunk ones over there, and then we'll reprint the base plate with a better solution. Also, these ones in the front kind of get in the way of the ESC, so yeah, probably better to go the other direction anyway. Alright, so I got the ESC fitted in here. There's a little bit of a clash, and the whole pattern of the inserts got messed up because they sort of shifted as I was inserting them due to the short height of them. So the base plate definitely needs some rework, but we're getting there. So I'll come back when I've got new parts and a new set to fit up on here. Alright, I'm a bit sick right now, so apologies if my voice is a bit off. This is the base plate that I just took out. This is that insert that I pulled through on accident. I did quite a bit of modifications between this base plate and this new one. The new one is a good bit thicker, allowing for a longer insert. And I also changed the screws to install from the top down. So you can see that countersunk head there, and then underneath, they're not nylocks right now, but they will be nylocks. Really hard to see with the lighting as it is, but you can see the nut there. Those will be nylocks eventually, and that will hold on the enclosure. 4 bolts should be plenty. Overall sizing seems pretty decent. On initial inspection, these bend radiuses for the phase wires are going to be pretty dang tight in here. So my goal right now is get these 2 MR60 connectors soldered on, and we'll plug them in and we'll see if we can stuff everything in here, because the power switch also needs to fit right here. And then these cables, I think I'm gonna have to solder out sideways and route around to the front and come down through the hole right there. And right now I'm thinking about soldering on the XT90 power for this just straight onto the cables that come through and making it trapped, because it's really easy to take it off if I need to, but I haven't fully decided yet. So we'll put on these MR60s. I'll be right back. So I got the connectors here installed, and I actually packed everything together and put the lid on this one, and it did fit, so that's excellent. However, when doing that, I noticed that these glands got really close to these motors, or that they are rather, and before I solder on the XT90 and make this harder to take off, I want to make sure that the base plate is good, because now if I want to move this forwards a little bit, all I have to do is just adjust the file and print it again. But if I wait, then I have to take connectors off, and that's really annoying. So let's check real quick. This might be really hard to show on camera, but it doesn't seem like they're gonna touch. Now it is really close, like within 5 millimeters or so, but apparently my truck is not evenly tight. You can sort of tell by the bushing compression down there. So this side probably needs to get compressed a little bit more, and the clearance on the left side is really not that bad at maximum. So I think we're gonna call it good for now, but before I release any files or offer this for sale. I'm going to adjust the holes so that the box is sitting as far forwards as I can. Another option would just be to lower the motors 1 notch on the gear drives, but if it clears, it clears. Alright, so now what we're going to do is solder the XT90 onto the ESC, and then we will probably go ahead and program it and make sure that everything's working. We'll plug in the Hall sensors and do motor detection, whatever, in the VESC, Flipsky ESC tool. And then once that's all together, then we can button it up and test it out, I guess. We need to connect the charge port as well. That can be done with the ESC out. So maybe I'll do that first. Alright, so I got 2 pieces of 14 gauge wire here. Red and red because I ran out of black. But we're going to solder these onto the plug at the back of the enclosure, and then solder an XT60 onto them, and that will be our charging connection. Alright, I got the charge port at the back soldered up, looks really nice. Got XT60 connected on here. Now this can go through the bottom of the enclosure and down to the battery. Alright, so I am ready to plug it in the rest of the motor stuff. However, I need to make sure that these Hall sensors work properly. So I looked at the pinout on the ESC, and it's pretty obviously different than the one that's on the motor. So basically what I did to figure out what this is, and I'm pretty sure I'm right, is I measured from 5 volts, which is pretty obvious. Usually 5 volts is red. And I used the diode mode on the multimeter, the little triangle diode. Measured from 5 volt to these 3 wires. They were all 2 volts. And then to the black wire, it was 1.7. So to me, I'm pretty sure that the yellow, blue, green are the Halls. The black is the ground. And then I measured from this one to ground with the resistance mode, the ohm on the multimeter, and it was 12 kilo ohms. And that's in the right range for a thermistor, so I'm pretty sure the white is the temp sensor. So basically what has to happen now is to match the ESC side, we need to move the white one next to the red one and the black one to the end. So we're going to do that real quick. Alright, so I got the cables switched around, so now we can go ahead and plug these into their respective Hall sensors. So it goes 5 volt temp, Hall, and ground. So we now match that up. And yes, these are technically not the correct connector. Obviously you can see that this clip doesn't go on to anything. However, the pins do fit in the holes and they're the right spacing. So I think it'll work. If it doesn't detect, then we'll have to make custom adapters. But as far as I'm concerned, this should work just fine. It's not like we're putting hundreds of amps through this or anything like that. So we've got those hooked up now, and I think that's everything we need to turn it on. I did connect up the XT90 down here. We got the XT60 for charging, so we can plug in the ESC. Also plugged in the USB cord for the ESC. It's actually really convenient that the USB comes out of a locking header on the board rather than being built in, because these USB-C headers are really weak when they're on a board, and these are much stronger. So really interesting, unique design decision, but I like it. So we'll go download the Flipsky programming tool, and I'll boot it up. I'll read the Flipsky page about programming this. Should be pretty simple. That's going to be a separate video, so I'm not really going to include any of it here. But we'll program this up, and then once it's programmed up, we'll fit everything into the box, close it up, make sure the remote's working and stuff, and then we'll move on. All right, so I went ahead and plugged in the power, plugged in the switch, turned it on, worked. I was able to get it to come up on Bluetooth. However, I have a firmware version error, and apparently this feature will not be developed yet, whatever that means. I'm trying to connect on my computer. I haven't gotten to it yet because my desktop has some issues, so we're going to try it on my laptop now. Alright, so we just finished the ESC setup with the VX4. Everything went fairly smoothly, and now it all works. So now that we've confirmed that, we can try to pack everything into this box. I think it's going to be really tight, but will fit, but we're going to have to see. Wow, that actually did it. Amazing. All right, there we got some of the major screws in around the outside. Now we can look and make sure we're not squishing anything important, which I think we're not. And then we can slowly tighten it all down. Excellent. Alright, so we have come to the end of this video. We have the enclosure installed, we have it all programmed, got the remote hooked up, and it works. Now, the next part of this video, or I guess next section, is going to be testing it out. The testing process for this is going to be a little bit of guess and check. I don't really know if the BMS in this battery will cut off hard at 100 amps or not. So we're going to have to be really careful going into this because I would not want to have myself at 30 miles an hour and then get it cut out. That would suck. So it's going to be guess and check. I'm probably going to do the torque testing first so I can try and draw maximum motor amps, see how the motors do. We'll ride it around a bit, see how it performs, and then we'll go in and adjust the settings in the Flipsky app and maybe change some settings on the remote if necessary. But overall, I'm really happy with how this process went. I like that it's very easy to add a different enclosure on here. All you need to do is hook up to the XT90 and the XT60 down here for charging and for discharging. Fun fact, the XT90 that is the discharge has an XT90S, which is great because that means there's no spark when you plug in an ESC. So good, nice to see that from Meepo. Again, this is a old unit. This is a, I guess, second or third batch or something of this board. So yours may differ a little bit, and this is only a 2P battery. So with all that in mind, hopefully you guys enjoyed this video. I will be making a follow-up with the performance testing, and yeah, let me know if there's anything you want me to change, and let me know if you'd be interested in seeing this, but not with the Flipsky ESC, with something that's really powerful, because I think that would be super cool as well. But yeah, let me know down in the comments below. Thanks so much for watching. Stay safe, keep on riding, and peace out.